Okay, welcome to this video. We'll be having a look at a practice paper for the Paper 3 higher tier exam. This is a calculator paper, so if you're following along, make sure you have a calculator. As always, this is just a practice paper. There is no guarantee that any of these topics will appear, but this is the second version, so hoping to cover a lot more topics that maybe weren't covered in that first version, but do make sure you check out the first version as well. As always, make sure you use the full checklist of topics that can appear on exams, and you've got a link for that in the description. And as always, there's lots of links to all of the topics that we go through in this video in the description as well that you can use to help with your revision. Now this paper will have a QR code on the front, so you can always get back to this at any point, but there are a lot of topics to go through, so we're going to get started on our first question, which is using a calculator. Now this one here, you just need to make sure that when you type this in, that you have exactly on your calculator what's written on the paper. So I'm going to type it in. If you've got your calculator, then you can check and make sure that you are getting the same answer as me. But when I type that in on the calculator, I get 157 point, and it does say write down all the figures. So 157.668255. For part B, it says to write my answer correct to 4 significant figures. So we're going to round this to 4 significant figures, which is 157, and it's 66, so that is going to round to 7. And there we go, there is my answer rounded to 4 significant figures. Question 2 here is expanding 2 sets of single brackets. So I'm going to expand the first bracket, which is timesing by 3. That gives us 3m plus 15. The second bracket, because we have a minus here, I'm actually going to expand this second bracket by negative 5. So that gives me minus 5. And negative 5 times negative 3m is plus 15m. Be really careful here, because if you times 5 by negative 3m, you might accidentally write minus 15m, but we're taking away everything. So it does flip the symbol there. So just watch out for these when that does appear. From here, we need to collect like terms. So 3m and 15m in total makes 18m. And we have plus 15 minus 5, which gives us plus 10. So our final answer there is 18m plus 10. Our next question is looking at some percentage profit. So here it says we have 20 chocolate bars and the box costs £9.80 and he sells each chocolate bar for 65p. Well, straight away we can work out 20 times, and I'm going to write it in pounds, 0.65. I'm going to type that in on the calculator and that comes out as £13. So that's how much he sold them for. We can use that to work out the profit. So 13, take away the £9.80 that he paid for these chocolate bars, that gives us a profit of £3.20. So when working out that as a percentage, we write it like we would a test score. He got £3.20 out of the original £9.80. So it's the change or the profit over the original, and to convert that to a percentage, we'll multiply it by 100. We just need to type that in on the calculator. So £3.20 over £9.80. And then we'll times that by 100, and that comes out as 32.65306. There are quite a lot of decimals there, but it does say give it to 1 decimal place, which did give us a hint there that it was going to be a not so nice decimal, and that comes out as 32.7. And there we go, there is some percentage profit. Our next question is looking at fractions, but it's a show that question, which does mean I need to do this using a non-calculator method. So for the first one, we will convert that to an improper fraction. 2 times 8 is 16, plus the 5 is 21 over 8. The next one, 1 1/6. 1 times 6 add 1 is 7 over 6, and we're dividing these fractions. Now there are different methods for dividing fractions. I'm going to use the keep, flip, change method, where I just multiply by the reciprocal. I can now do 21 times 6, which is 126. And 8 times 7, and again, even though they're nice easy multiplications in terms of the 8 times 7, we're still going to use the calculator just to double check, make sure these are alright. So a few 56s, 56 add 56 on the calculator is 112, so it does fit in twice, and the remainder from 112 to 126 is 14. So 14 over 56. Now 56 actually divides by 14, but I could type that into the calculator just to double check, make sure I'm getting it right, and it does come out as 2 1/4. So the fraction there, the little fraction with my 2, I've divided it by 14, and I get 2 1/4. So if I'm going to show that this is less than 2 1/2, well, 2 1/4 is less than 2.5. And I could write that in words, or I could write it using an inequality, but I have shown that the calculation there is less than 2.5. So there we go, just some fractions with a show that variation. Question 5, we have some forming and solving equations. It says all these measurements are in centimetres, but the area of rectangle A is equal to the area of rectangle B. Well, the area of a rectangle is multiplying the side lengths. So here we have algebraic side lengths, so 4x times 2.5. I could do 4 times 2.5 on the calculator, but it comes out as 10x. And over here we have 7 lots of 2x minus 3. Now that comes out as 14x minus 21. And it says that those two areas are equal. So I can set them equal to each other. 14x minus 21 is equal to 10x, and I have an equation that I can solve. It does eventually want me to work out the perimeter of rectangle B, so once I've got the value of x here, which I can get relatively nicely, I can take away 10x from both sides, which leaves me with 4x minus 21 is equal to 0. I can then add the 21 to the other side, which gives me 4x is equal to 21, and then I can divide by 4, and 21 divided by 4 is 5.25. Now I know the value of x, I can substitute it back in, and I can actually figure out the value of this perimeter. So 2x minus 3 is 2 times 5.25, and then take away 3. So I can do that on the calculator, times that by 2, take away 3, and I get 7.5. So this length here is 7.5, this is 7.5, and of course the other side of the rectangle is the same as on the right, so 7. I can now add those all together, so 7, add 7, add 7.5, add 7.5, and that adds up in total to 29. And it did say it was all in centimetres, so 29 centimetres is the final answer. On the dotted line, we've got no centimetres there, so we want to write the units 29 centimetres. Okay, on to our next one. This is quite a long-worded question. It says Amira is helping to organise a charity cycling event, and they are circular cycle tracks. Each track can hold a maximum of 15 cyclists, and there are 289 cyclists. Each circular track has a diameter of 25, and she needs to mark the outer edge of each track with a special paint, so the circumference. So the circumference formula is pi times diameter, or 2 pi r, whichever you choose to use. In addition, she will also paint a 150 centimetre finish line on each track, and each can cover 50 metres of line. How many cans of paint does she need? So we've got a lot of information here. One of the things that has just stood out to me is that 150 centimetres is in different units. So that is 1.5 metres. So we need to work out the distance around a track, and there's going to be the extra 1.5, and we need to know how many tracks we need. So if we do 289 cyclists divided by the 15 maximum cyclists allowed on each track, well, 289 divided by 15 comes out as 19.26 recurring, and that means we're going to have to use 20 tracks. So we're going to have to use 20 tracks to fulfill this, to make sure that we have enough tracks for all the cyclists, and we're going to need to work out the distance that we need to paint for all of those tracks. So if the circle has a diameter of 25, well, we can do pi times the diameter of 25, and we can type that in on our calculators. That comes out as 78.539, and a few more decimals there, but I also need to add the 1.5 metres for each track. I could add all the 1.5s at the end, but I'm going to add it right now just to get the total distance needed for one track, which is 80.0398164. So that's the amount of paint we need to go on one track. And of course, we need 20 tracks. So if I times that by 20, that's going to tell me the total length or distance of paint that I'm going to need, and that gives me a total distance of 1,600.796327. Now it says, of course, that each can covers 50 metres of line. So if each can covers 50 metres, to find out how many cans I need to divide this by 50. So on my calculator, divide by 50, and that comes out as 32.01592654. Now, although that is super close to 32, it is actually just over, so I would need to round that up to make sure I cover it all. It is 33 cans. Of course, this is such a small distance, we could actually probably in real life get away with 32, but if it ever goes over, we are going to have to round it up there. So our final answer is 33 cans. And there we go, there is our final answer. That was looking at some problem solving and circumference of a circle. Question 7 says Priya buys a bicycle. She gets a discount of 8% off the normal price. Priya pays 506, work out the normal price. So if she's got a discount of the original 100%, take away 8, she's actually paid 92%. So 92% is equal to £506. We want to know 100%. I'm going to divide down to 1%. There are two different methods, I guess, that you could logically do for this. You could use a reverse multiplier, but I like this one visually. I think it looks really nice. And that comes out as 1% is equal to 5.5, and it's dead nice to get back to 100%. Times by 100, you get £550. So there we go. On to our next question. We are looking at compound interest. Zane invests $7,200 in a savings account. It gets compound interest of 3.1% in the first year and 1.9% for each extra year. So if we get 3.1%, well, 100 plus 3.1 is 103.1%. If you divide that by 100, you get your multiplier, which is 1.031. For the next one, it follows the same pattern. It's 1.9%, so it's 1.019. Now, most of these multipliers do start with 1.0, and then it's just the percentage following that. Obviously, you just got to watch out. If it's in the tens, like 31%, it'd be 1.31. Just make sure you know your multipliers really well. So in the first year, we are going to get 3.1%, so we would times by 1.031 for the first year. For every extra year, we get 1.9%. So for the second year, we'll get 1.019 as our multiplier, and because it's 3 years, we're going to get that for 2 years. So I'll put squared with that one, and that'll make sure that that multiplication is done twice. We can just type the rest into the calculator. So 7,200 times 1.031 times 1.019, and we can square that. We get our final answer. It comes out as £7,707.96. There are a few decimals after that, but we're going to round it to the nearest penny because the 1375 here isn't in our monetary system. So £7,707.96 as our final answer for that compound interest. Okay, our next question is looking at some column vectors. It says the vector A and vector B are shown on the diagram. On the grid, draw and label the vector B plus 2A. Now the vector B here, we can read what that is. It goes across by 1 and it goes down by 3. Vector A goes across by 1, but it goes up by 2. So as column vectors, A is 2 and 1. Wrong way round, 1 and 2. There we go. And B is 1 and negative 3. So there we go. A goes across by 1 and up by 2, and B goes across by 1 and down by 3. So if I want to do the vector B plus 2A, I have 1 and negative 3, and we're going to add to that 2 lots of A, which is 2 and 4. We can add those together, so that gives us 3 on the top and 1 on the bottom. So that vector there goes across by 3 and up by 1. So if I'm going to draw and label that on the diagram, I need to pick somewhere where I have space to go across by 3 and up by 1. This one looks like a good space. So across by 3, up by 1 gets me to here. So I'm going to join those up. I'm going to draw an arrow in that direction that it's going in, and I'm going to label it B plus 2A. And there we go. There is my column vector drawn. Of course, reading the vectors, do make sure left and right goes on the top and up and down on the bottom. So there we go, there is drawing a column vector. Question 9 is looking at some inverse proportioning context. It says on Monday, 8 builders took 6 days to build a garden wall. On Wednesday, 12 builders were hired to build an identical wall. Assuming all builders worked at the same rate, work out how many days it would take the 12 builders to build the wall. So here we want to work out how long it would take one builder to build the wall out of this scenario. So if 8 builders take 6 days, well, one builder would take 8 times 6 days, or 8 times longer. So 8 times 6 comes out as 48, so it would take one builder 48 days to build the wall. But in the second scenario, we're using 12 builders. So 48 days divided by the 12 builders, again, relatively nice divisions here, but that comes out as 4 days. So there we go, it would take 12 builders 4 days. Remember, our answer should make sense here. If 8 builders took 6 days, 12 builders should do it faster, and it would be 4 days. Now it says here the assumption is wrong. How might this affect the time taken for the 12 builders to build the wall? Well, the assumption was just here, assuming that all builders worked at the same rate. Now, there could be two scenarios. The builders could work faster or they could work slower. So it might affect our answer in two different ways. So I would write something along the lines of here, well, the time taken could be higher or lower. It could be either way. The builders could be fantastic, they could work faster, or the builders could not be so good and it would take longer. So an answer there that says the answer could be higher or lower. Question 10, we are looking at a cumulative frequency table. So here we are given two tables, one with the frequency and another blank one to put in our cumulative frequency. So to start with, we have 5. Then we are going to add 30 from the next one. And we're just going to keep going, adding each extra number, adding 20, adding 15, adding 8, and adding 2. And we should know that we're correct at the end here if it tells us in the question how many it's related to. Here it was related to 80 students. We've got 80 at the end. So it says on the grid, draw the cumulative frequency graph for this information. So when we are drawing a cumulative frequency graph, we are going to plot on the end points, which are just here, against that cumulative frequency. So 20 goes to 5, which is just here, a little awkward there with the scale. The next one, 35 and 55. There's 35, there's 55. And then we have 70, 78 and 80. So 70, 78 and 80. And there we go, that's on the endpoints. Now this one also had a starting point of 0. So this one, we are going to connect it to the 0, and that's going to be the start of our cumulative frequency curve. And from there, we're going to draw a nice smooth curve, which should go through all of these points. Hopefully I can hit them perfectly. There we go. And there is our cumulative frequency curve. Now it says here, use your graph to find an estimate for the percentage of these students who spend more than 90 minutes revising. So we need to find 90 on our axes, and we're going to go up to the curve. We're going to see how many people revise up to 90 minutes. We need a nice straight line. We want to read this as best as we can. They're all going to be ever so slightly different, although they should be around about the same value. And there we go, that lands on 74. Each square there goes up in 2s, so just double check very carefully. That is 74. Now the language here says, how many students spent more than 90 minutes revising? Well, from 74 to 80, that's an extra 6. So as a percentage, well, 6 out of 80, which is a fraction, spent that extra or more than 90 minutes revising. We want it as a percentage. So if I type this in on my calculator, 6 out of 80, I'm going to times that by 100. And on my calculator, for that exact value that I've got there, it comes out as 7.5%. So there we go, writing it as a fraction, timesing it by 100, and just remembering it was just the extra bit there as we were looking over 90. Okay, so there we go, that was a cumulative frequency graph. Okay, so for this question, we're looking at the volume of a compound shape, which is made out of a hemisphere and a cylinder. So for this one here, it says we have this container that's been made. It says the hemisphere and the cylinder both have a radius of 6, the height of the cylinder is 10, and there's water to a depth of t centimetres, and it says the volume of the water in the container is half the total volume. Work out the value of t. So we're trying to work out the height of the water there. So what we can do is we can actually work out the volume of this shape. To start with, we can start with the hemisphere. It is a sphere formula given to us, so we do want to half this formula, which is going to be 2/3 rather than 4/3. So 2/3 pi r cubed. That will give us the volume of the hemisphere. So we can do 2/3 times pi times 6 cubed. And if we work that out, we could always write all the working out and do it all in one go, but it is good to get one of the answers written down first. That comes out as 144 pi. We can write it as a decimal or leave it in terms of pi for the moment. And that is the hemisphere, which you can label. We can then work out the volume of the cylinder. Now the volume of a cylinder is pi r squared multiplied by the height, so pi times 6 squared. times by the height of the cylinder, which is 10. Again, type it in on the calculator, pi times 6 squared times 10, and that comes out as 360 pi. Now you can write these as decimals if you prefer. I just prefer to keep it quite clean and leaving it in terms of pi, so I can add that to the 144 pi. So overall, the overall total, which I'll label as the total here, is equal to 504 pi. So that is the volume of the overall shape. Now it says that the water is half the total volume. So if I divide that by 2, which will give me the volume of the water, divide it by 2, that gets me 252 pi. So the volume of the water is 252 pi. There we go, there's a key number. We now want to work out what height that would give us. So of course the height of the water there is just forming a mini cylinder in the middle of the shape. So we want to write out the formula, again, for the volume of a cylinder, except now we have our answer for the actual overall volume, 252. So the volume of a cylinder is, let's write down the formula with nothing in to start with, pi r squared times the height. We now have the volume, so 252 pi is equal to pi times 6 squared times the height, which they've called t. So all we need to do is reverse this. We can divide both sides by 6 squared times pi, which is 36 pi. So if we write that as 36, we could write 252 pi divided by 36 pi, and that's going to equal t. We can type that straight into our calculator. So my answer that I already had, divided by 36 pi, and I get t is equal to 7. And there we go, there is my height. So we had using the volume of a sphere as a hemisphere, so halving that, the volume of a cylinder, halving it for the total volume, and then working backwards with the volume of a cylinder. So quite a lot going on in that question, but we got the total height being 7. Okay, so for our next question, we are factorising a quadratic. So when factorising a quadratic, we have two options for this one, but we need to look at the numbers at times to make 4. So it's 1 and 4, or 2 and 2. Now one of the options could be 6x and 1x, and we just need to see, can we make 5 using those numbers? So if one of the numbers is times by 6, 1 and 4 could be 6 and 4, which we wouldn't be able to make 5 with, or 24 and 1, that definitely doesn't work. 12 and 2 for the next one, and that doesn't work either, which means that this has to be a 3x and a 2x, which means one of the numbers gets times by 3 and one of the numbers gets times by 2 if we use the inspection method. So to make 5, we could have 3 and 8 for the 1 and the 4, and actually that works. So 1 goes over here, we want that to be times by 3, we want the 4 to be times by 2, and that would make 3 and 8. We just need to get the order the right way around. I want minus 8, add 3, and that would give me negative 5. And you can always expand this. 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 4 times 2x is minus 8x. That gets us that negative 5x we were looking for. And negative 4 times 1 is negative 4. So there we go. There is my factorised version. 3x minus 4 and 2x plus 1. And of course you can write those brackets in either order. And there we go, factorising a quadratic. So next question says y is directly proportional to x, where x is greater than or equal to 0. Sketch a graph that represents this relationship. So we've got the positive quadrant, which is why it says x is greater than or equal to 0. Direct proportion is just a nice straight line going from the origin, and we'll just have a nice straight line like that. And there we go, there is our direct proportion graph, and you could draw that at any angle there, as it doesn't give us any further information. Important part, it's just a nice straight line. And there we go, 1 mark for that one. Question 14 is making m the subject of a formula. So we need to multiply this denominator over. I tend to always put it in a bracket. And when we times by m minus 3, both sides, we get p lots of m minus 3 is equal to m. We need to expand this left-hand side. So pm minus 3p equals m. We're trying to make m the subject. So we want the m's on the same side. So we can add 3p to the other side. And then we'll minus the m over, and we get pm is equal to m plus 3p minus the m to the left. Pm minus m equals 3p. Now we can factorise this. We can take m outside the bracket, and it'll be p minus 1 equals 3p, and then you can divide by the bracket, and you get m is equal to 3p over p minus 1. And there we go, there's our rearranged formula. M is equal to 3p over p minus 1. There is another variation of this where you could move the pm to the right. You would have had a minus 3p at that stage, so at this stage here, we'd have left this as minus 3p, we'd have had minus 3p equals m minus pm, and then you could have rearranged it that way as well, and that's absolutely fine too. Question 15 is looking at upper and lower bounds. This one here wants us to work out the upper bound for this, and it wants us to work out the answer to 4 significant figures. So with any bounds question, whether it's a bounds question like this or with compound measures, the first thing we want to do is write down the error intervals. So I'm going to write down the error interval for y to start with. So y is between 14.76, so I'm just going to add the 5 on the end, and 14.755. For x, we have 8.215 at the end, and 8.205 for our smaller one. Z, and not forgetting our error interval arrows there, we have 2.65 on the end and 2.55. And there we go, there's our upper and lower bound for each number. From here, if I want to get the biggest possible answer for B, I want to have the biggest answer on the top, or the biggest number on the top, and divide by the smallest possible combination on the bottom. So to get that upper bound, I want to use the bigger value of y. And to get the smallest possible answer on the bottom, I want to take the smallest x and take away the biggest z. That would give me the smallest possible number on the bottom there, on the denominator. So if we put those pieces in place for the upper bound, I have 14.765, and I'm going to divide that by 8.205, take away the biggest answer there to give me the smallest answer on the bottom. And there we go, I can type that all in one go. 14.765 over 8.205, take away 2.65. And that gives me 2.6579. It's a recurring pattern of 6579. But it wants it to 4 significant figures. Hopefully that won't affect it. I won't have to keep writing it out. 1, 2, 3, 4. There we go. After the 7, it's a 9, so it does just round it up there. So that becomes 2.658. And there we go. That's now to 4 significant figures. And there we go. That's my final answer. 2.658. Just watch out, because obviously all these formulas, there are so many different variations of a formula. You just need to think very logically about the formula. How do I create the biggest or the smallest number on the top or the bottom to follow that little rule there? When there is the division involved, especially, to get the biggest answer, you want the biggest divided by the smallest, and to get the smallest or the lower bound, you want the smallest divided by the biggest. And there we go, there is some upper and lower bounds. Question 16, we have a trigonometric graph, and it says using the graph find estimates to the solutions of sine x equals 0.4 between 0 and 360. So between 0 and 360, that's what we have here. It goes up to 360 and starts on 0, and 0.4 we just need to find. Here is 0.5, so it's 1 square below that. So we'll just take a ruler and a pencil. We're going to go across, we're going to go through the curve at those points. There we go, it only crosses through at 2 points on this one. So I'd go down, read that value, come down and read this value. I just want to read each square carefully. Each one here goes up in 30s, so that's 30 and 60. There are 5 squares between each one, so each square goes up by 6. So I want to read that super carefully, make sure that these lines are drawn nice and neat, so you can read that. That is 6 below the 30 there, so that is 24. And this one here, if I count up 120, 150, and it's 1 square above 150, so 156. So there we go, there are my 2 solutions using the graph there. We have 24 and 156. Okay, part B is looking at a graph transformation. It says on the grid, sketch the graph of y equals f of x minus 2. So lots of different graph transformations. This one here is a minus 2. It's outside of the x bracket, which means it affects the y coordinate, and it does what we expect. Minus 2 moves each point down by 2. So check the scale on the axes. find nice whole number points. I'm going to go for right at the end here, 1, 2 down, and we're going to go for this top one up here, 1, 2 down. There we go, and that has moved each one down by 2 because it's a nice straight line. I don't need to connect too many points, I just need to get these ones perfect. There we go, try and join that up with a nice straight line, obviously using a ruler and a pencil, and there is a graph transformation. Okay, on to our next question, and we are looking at an algebraic fraction. Now just be really careful here that we look at what operations are taking place so that we follow these in the correct order. This is 2 subtractions here, so we're just going to do this left to right. We're going to first take away both of these, and remember we're looking to get it into this form in this question. So here we have 4x over x plus 3. We're going to need a common denominator, so we're going to times this side by the x minus 3 on the other fraction. And we have 3x plus 2 over x minus 3, which we're going to times by x plus 3. So the numerator on the left here, we're going to have a single bracket to expand. We've got 4x lots of x minus 3, which will give us 4x squared minus 12x. On the bottom, we do have a double bracket to expand here, but it is a difference of 2 squares. X plus 3 times x minus 3 is just x squared minus 9. We're going to take away, and we have a double bracket to expand on the right here. That one there probably is worth expanding to make sure we get that one correct. So x plus 3, and that's going to give us, I'll do the working out to the side, 3x squared plus 9x plus 2x plus 6. So we can simplify that on the top. We get 3x squared plus 11x plus 6. And again, that's all over x squared minus 9. So take your time when you are subtracting these. We do have a subtraction here, so be very careful because we have 4x squared, take away 3x squared, and that gives us 1x squared. And then on to the next one, we have negative 12x, and we're taking away 11x. So negative 12, take away plus 11, which is negative 12 take away 11, which is minus 23x. And then we also have take away the 6. So we're taking away plus 6, so we end up with minus 6 on the top, and that is all over x squared minus 9. So that is the first 2, which we have now subtracted, and now we have to subtract 1. So we have x squared minus 23x. I keep going to write the x, let's change that to 23x minus 6, and that's all over x squared minus 9. Now 1 will just be x squared minus 9 over x squared minus 9. Obviously, when you divide anything by itself, you get 1. That gives us the common denominator that we're looking for. So this is 1, and we're taking that away. And again, I just need to be super careful here, like we did before, that I remember we are doing a subtraction. So we have x squared minus x squared. They actually just cancel each other out. So they're gone, no more x squareds. And we have minus 23x, and there's no other x's over there. So minus 23x on its own. And the last piece, we have negative 6, and we're taking away negative 9. But because we're taking away negative 9, that's negative 6 add 9. So negative 6 add 9 is plus 3. And again, you could write that down to the side. Minus 6, take away minus 9 is minus 6 add 9. And there we go. That's all over x squared minus 9. So in the question, it's now in that form that it wanted, ax plus b. A is negative 23 and b is 3. And on the bottom there, we have x squared minus 9, which is exactly what we've got. So minus 23x plus 3 over x squared minus 9. And there we go. Right. Okay, so this question says a smoothie recipe uses 4 ingredients: banana, mango, yogurt and honey. The total weight of banana and mango is 3 times the total weight of yogurt and honey. The weight of banana is 2/5 the weight of mango. The weight of yogurt is 80% of the weight of honey. Find the ratio of the weight of banana to the weight of mango to the weight of yogurt to the weight of honey. Now, when looking at this question, I did sort of think to myself, is there an algebraic way of doing this? But I think actually one of the easiest ways of answering this question would just be to sort of pick one of these and give it a number. So here, I think if we pick honey, and there are other ways of doing this, but let's imagine we go for honey. Now it says that yoghurt is 80% of the weight of honey. So I want to pick a nice number that I can do 80% of. I don't want to go too large with that number, but if I say that honey is 10, and then if yoghurt is 80% of that, then yoghurt would be 8. So if I start to write this out as a ratio, banana, mango, yoghurt and honey, I've got 10 for the honey and 8 for the yoghurt. And for the moment, that works perfectly. We do have one is 80% of the other. Now it says that the total weight of the banana and mango is 3 times the total weight of the yoghurt and honey. Well, the total weight at the moment of the yoghurt and honey, based on the numbers that we've used, is 18. And that means the banana and mango has to be 3 times that. And if we times that by 3, that is equal to 54. So we now know the total weight of the banana and mango using these numbers. It says that the weight of the banana is 2/5 the weight of the mango. Well, if we say that the mango is then 5/5, the banana is 2/5. So in total, looking at that 54, that is 7/5 of that weight. Again, just writing this down, if the banana is 2/5 of the weight, the mango is the full weight, which is 5/5 or 1 mango, and therefore it's 7/5 in total. So if we want to find the value of the 2/5 and the 7/5, we'll have to do 54 divided by 7, and you'll notice when you type that in on your calculator, you don't get a very nice answer, you get quite a long recurring decimal. That's fine, we're going to divide it by 7 and times it by 5. And for the mango, that gives me 270 over 7. Not a very nice number, but that's fine. We'll deal with it in a little bit. So just to reiterate there, we've done 54 over 7 and times it by 5, like a reverse fraction there for our mango. And for the banana, 54 divided by 7 and times it by 2, because that's 2/5. So 54 over 7 times 2, and that gives us 108 out of 7. So there we go, we now have a ratio. We have 2 not particularly nice numbers in there, but we can clear the fraction by timesing all of these by 7. That will get rid of that denominator there, it will turn them into nice whole numbers. So let's times them all by 7 and see what we get. Banana, mango, yoghurt and honey. We get 108 for banana, 270 for mango, 8 times 7 for the yoghurt comes out as 56, and 10 times 7 is 70 for the honey. And there we go, there is the ratio for the weight of banana to the weight of mango to the weight of yoghurt to the weight of honey. Now you could write this in its simplest form, it doesn't say you have to, but of course all of these do divide by 2, so you could write that as 54, 135, 28 and 35. But any variation, any equivalent ratio there would be absolutely fine. We've just cleared out some of those fractions. So there are other ways of doing this. We could do this algebraically. However, I do think it's very nice there just to pick a number and follow through there. I think the difficult part though is probably this bit here where we had the 7/5 being equal to that 54 because one was 2/5 the size of the other. So that's 1 whole plus the extra 2/5. So it was like a reverse fractional amount there. You could turn those into percentages or decimals as well if you prefer to work with those. But there we go, there is the ratio for that one, and again I have written it in its simplest form there even though it didn't ask for it, so lots of different variations. You could write any equivalent version of that ratio too. So there we go, there was that one. We've got the dotted line down here, so 54, 135, 28 and 35. Okay, there we go. On to our next question, and we are looking at a circle theorem. Now this circle theorem here, it says A, B, C and D are points on a circle. TDV is the tangent to the circle. AB is equal to AD, which we can see there. We've got those little lines on the outside of the quadrilateral. Work out the size of BCD. You must give a reason for each stage of your working. So BCD, let's find that angle. That's just here. So thinking about this question, for starters, we have a tangent to a circle, which can involve 2 circle theorems. We have the tangent to a radius, but there's no radius drawn, and we can have the alternate segment theorem, where there is a tangent connected to a cyclic triangle. We also have here a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180 degrees. But we don't have any of the opposite angles. So we're going to have to try and figure this out. We do have an angle here between the tangent and the quadrilateral, but that doesn't really help us. We need it to actually be a triangle. So in order to create the alternate segment theorem, which we could do here, we would need an additional line drawn in. And that would mean that this angle here is 71. And that's going to help us a lot because this here, we've been told these two lines are the same length. And therefore, ABD, this triangle here, is an isosceles triangle. And that's obviously going to give us lots more angles within the shape. So adding that extra line in there has given us a big advantage now because now we can actually work around the shape. So there we go, that angle there is equal to ADT. So you had ADT, you could write this down below or label it, is equal to ABD. And that's due to the alternate segment theorem. And we'd write that all in nice and clear. And there we go. And now we can work out this angle here because base angles in an isosceles are equal. There we go. And we'd again write this reason in. Base angles in an isosceles are equal. And we can now find the top angle in the triangle as well. Angles in a triangle add up to 180 degrees. So if we do 180 and we take away 142, that's going to give us 38. That's the top angle there in the triangle. We can now use the opposite angles in a cyclic quadrilateral to find our missing number that we were looking for because those two numbers add up to 180. So 180 minus 38. And that we have actually already written down there. We've got the 271s, which is 142, which is exactly the same. It's just working backwards there to get that 142. So that final answer is 142 degrees. And again, the reason for that, opposite angles in a cyclic quadrilateral add to 180. We did also have the rule there that angles in a triangle add up to 182 when we were getting the 38. But there we go. There is all of our rules that we need to write down for that. And there we go. There is our circle theorem question for that one. Now I've obviously written that over the diagram. You can label the diagram, you can write it down below. Absolutely up to you as long as it's nice and clear. Of course, it's easier for me to write on the diagram here than scroll up and down. But there we go, there is the answer to that one. Finding the size of angle BCD and giving all of our reasons for that. Of course, lots of different types of circle theorems, but there's hopefully a nice one where we had to add an additional line in to actually start working around the diagram. Okay, so question 20 is completing the square and also writing down the coordinates of the turning point of the graph. So here we have the coefficient of x. So here -6 divided by 2 is -3. So we have x minus 3 squared. That's our squared bracket. And then think to ourselves, well, what does that equal when we expand it? We end up with +9 at the end. We don't want +9, we want +4, so we take away 5. And that's completed square form. Dead quick. Only takes a little bit more time when you do have a coefficient higher than 1 in front of x squared. So do make sure that you check those ones out as well because they're quite key. Would be involved in a slightly harder question. And then finding the turning point of the graph, we look at the number in the bracket. That one, the symbol flips, so 3. And the number on the outside of the bracket is our y coordinate. And there we go, -5. It is just that coordinate inside the bracket though that changes signs. So +3 and -5. Okay, so for this question, it says to work out the exact value of x and give your answer in its simplest form, and you must show all you're working. Now in this question here, we've got quite a lot going on, but the first thing to notice is these are all powers of 2 in some form. So what we're going to do is we're going to apply laws of indices here, but we need to get all of these numbers to become powers of 2. So for the first one, we have 2 to the power of x, which is already a power of 2, that's fine. Now that is equal to, on the numerator there, 32 is 2 to the power of 5. Root 8 to the power of x. Now I'm going to do that one to the side because there's quite a lot there. So 8 to start with is 2 to the power of 3. And the square root is when we put something to the power of a half. So if we convert that to a power of a half, then we have 2 cubed to the power of a half, which is equal to 2 to the power of 3 over 2. That is all also to the power of x. So that is to the power of x. Again, multiplying powers there, we get 2 to the power of 3 over 2x, or we could write that as 3x over 2, whichever you prefer. So there we go, we can put that in now. So that's 2 to the power of 3 over 2x. On the bottom, we have 4 to the power of x minus 1. That's 2 squared, which is what 4 is, and that's all to the power of x minus 1. So that is 2 to the power of 2x minus 2. Again, just times in powers in brackets. So that's 2 to the power of 2x minus 2 on the bottom. Now they all have the same base number, we can apply laws of indices. So looking at the numerator to start with, we have 2 to the power of, and that's adding powers when we're timesing, so 5 plus 3 over 2x. And on the bottom, we still just have 2 to the power of 2x minus 2. Now we can subtract the powers. So if we take away the powers here, we've got 2 to the power of x equals 2 to the power of 5 plus 3 over 2x. Subtract that power on the bottom. We're going to have to be really, really careful here because we are taking away a minus 2 at some point as well. So we have minus 2x, and when we take away negative 2, that's going to become plus 2. As we are subtracting that power, the symbols do change there. So now we have this situation here where we have 2 to the power of x is equal to 2 to the power of all of this. So the powers now are equal. So we can just get rid of the 2's and we can just say that x equals 5 plus 3 over 2x minus 2x plus 2. Now we do need to simplify and solve this, so let's add some of these pieces together. We have 5 add 2, which is 7, if we collect the numbers. So x equals 7, and we have plus 1.5x minus 2x. You can do that on a calculator, but 1.5 take away 2 is minus a half, so we get minus a half x. Okay, so we're very, very close to solving this. We could add this half x to the other side, and that gives us 1.5x, or 3 over 2x, equals 7. And then 7, we need to divide by 3 over 2. To be fair, you could do that without a calculator. You could just times by 2/3, and it gives us 14 over 3. And again, that's in its simplest form there as well. So x is equal to 14 over 3. And there we are, there's our final answer, 14 over 3. And there is our value. So that was all about changing the numbers into their base numbers. Just watching out, this little step here was quite a tricky one, where we went from here to here, because we were subtracting that power there, so the negative 2 turned to that plus 2. But other than that, relatively okay in terms of the equation once we'd got it. So there we go, on to our next question, and we are looking at a tangent to a circle. So for this one here, it doesn't have a diagram. Now when it doesn't have a diagram, I do like to draw a little sketch. X squared plus y squared equals 40 is a circle, centre 0. And there we go, a little sketch of a circle. And we have the coordinate 2, 6, which would be in this quadrant here, this positive quadrant. And there is a tangent to the circle going down, something like that. And there we go, we can draw that in. There's our little sketch. It says find an equation of the tangent to the circle at A and give your answer in the form ax plus by plus c equals 0. And we'll come back to that bit there at the end. So when we are working out a tangent to a circle, I need to think about the gradient of the radius. The radius is at a 90-degree angle to that tangent there. So I can work out the gradient as it goes from 0, 0. It goes up to 2, 6. So the change in y over the change in x. It goes from 0 to 6. So 6, change in x is 2. So the gradient is 3. So if the gradient is 3, the perpendicular gradient is minus 1 over 3. The equation of the line will be in the form y equals mx plus c. And we have now a coordinate and we have a gradient. So we just put all the pieces in place. So the coordinate at 2, 6, I'll write it here so we don't forget the numbers, 6 is equal to minus a third times by the x coordinate 2 plus c. We can type the minus a third into the calculator, but it's just minus 2/3. So 6 is equal to minus 2/3 plus c. And then we can do 6 add 2/3, which I will type in on the calculator because it will give it me as a nice improper fraction. We get 20/3 is equal to c. Okay, so I can put all the pieces into my equation of the line. So y equals minus a third x plus c. C is equal to 20/3. So replace that c with 20/3. And there we go. There is the equation of the line. Now it wanted it in a different form. ax plus by plus c equals 0, where a, b and c are integers. Now right now we have fractions involved. However, they are both fractions that have a 3 on the denominator. So we can times by 3 to remove those fractions. We get 3y equals minus 1x plus 20. It also wants it to be equal to 0, so it wants the x, then the y, then the number. So we'll just move them over piece by piece, add x to start with, so we'll put that at the start, so x plus 3y equals 20, then minus the 20, and we get x plus 3y minus 20 equals 0. And there is the equation of the line. Now it did say ax plus by plus c. You'll notice there's not a number written in front of x, and that's just because it's 1. Of course we don't need to write that, so we don't need to write that in, but there is our equation of the line written in that form. So x plus 2y minus 20 equals 0. And there we go, there is a tangent to a circle and the tangent written in a specific form. Okay, and on to a quadratic simultaneous equation. So for this one we have an x squared and a y squared. So we use the substitution method. So for this second equation I need to make it x or y equals. Here it's easier to make it y equals, so we'll do 7 minus 2x. And I'm going to substitute that in place of the y in that second equation. So when I do that, we have x squared plus 7 minus 2x squared, and that's equal to 34. From there, we can expand the double bracket, so x squared plus, and then I'll probably do 7 minus 2x to the side, just to make sure that we are absolutely perfect, expanding that. And that gives us 49 minus 14 minus 14, so minus 28x, and then plus 4x squared, and that's equal to 34. Okay, I need to tidy this up, make it equal to 0. So if I add together the x squareds, we get 5x squared. We have minus 28x. And then we also have to take away this 34 from the 49 so that it equals 0. And that leaves us with plus 15, and that's equal to 0. Now this quadratic may or may not factorise. But we don't need to worry about it. Because we're using a calculator, we can just find the values of a, b and c and use the quadratic formula. So if I do this to the side, a equals 5, b equals negative 28 and c is equal to 15, we can then put that into the quadratic formula. So minus b would give us plus b, so 28, plus and minus the square root of minus 28 squared, so make sure that goes into a bracket, minus 4 times 5 times 15, and that's all over 2a. Okay, so we can type that into the calculator. We can do it once with the plus and once with a minus. Just go back in, delete your plus for a minus, and we get two values of x here. We get x equals 5 and x equals 3 over 5. So there's our two values of x. We now just need to substitute that back in to either one of the equations. However, we do have an easier equation here, which is y equals 7 minus 2x. So I'll rewrite that down here. Y equals 7 minus 2x. And that means when we have x is 5, we have 7 minus 2 lots of 5, which gives us negative 3. And we have 7 minus 2 lots of 3 over 5, and that gives us 29 over 5. So there we go, we get two solutions. We get when x is 5, y equals negative 3, and when x equals 3 over 5, y equals 29 over 5. And there we go, there's our solutions. We can just write them like that, or a nice long list there. But there we go, that was our final question, looking at a quadratic simultaneous equation, and that was the end of this particular paper. And obviously remember, just like I said at the start, that was just a collection of topics, just a practice paper of unseen topics that may or may not appear in your exam. I did put 2 videos out, so if you haven't already, do make sure that you check out the other video, make sure you check out all the links in the description for all those different topics, but otherwise, I do wish you the very best of luck on your exam, and then I will either see you either for our next video, or this may be the last video for you, in which case, best of luck for your exams. Do wish you the best of luck. Please leave me a comment and let me know how you get on. Otherwise, best of luck.